How you doing today? So today I'm going to talk about uh, a Balluff IO Link master, which has a Ethernet IP port on it that communicates to the master on the PLC, and we're going to talk about connecting up some Festo sensors to that Balluff IO module, or IO Link module. Sorry. Um, this link here is wrong. I'll update this later when this video is finished. But basically, the layout that I'm going to discuss here is I've got a couple sensors that are connected to port 2 and 3 on the Balluff module. I got a Strata switch, PLC, general stuff. So the guide, or this YouTube video, if you look at the bottom of this YouTube video where the text is there, you'll see that there's a Dropbox link to all this code. There'll be user manuals as well as the Rockwell project file with all this information that we're discussing right now. And the AOI from Balluff is in there, and so on and so forth. So the first thing you need to do is wire the module, and this is the wiring right here. IO Link in general is pretty much the same on all devices. You've got 24 volts, 0 and 24 volt supply power, and then you've got an IO Link C/Q line, they call it, which is the data coming back from the module itself. The Balluff module today, I'm using these ports down here. I'm using ports 2 and 3 as we showed earlier, right here, 2 and 3. Basically, you've got some power coming into this port on the right-hand side here for, actuator sensor. In this case, because I'm only using sensors, I would not have to use the actual actuator power. The Ethernet IP is up top here, the ground, and then your standard wiring here. You don't need to use this is just a generic non-shielded cable. It's a 5 conductor in this case. Have some status on the Balluff module. And then we've got our PLC. Any PLC will do the same thing. It's all ControlLogix RS5000 or Logix Designer software. This particular project's done in version 21. Hopefully you can open it. If you don't, maybe leave a note in the YouTube remarks, and I'll perhaps try to convert it to some other version. But the Balluff module has got an add-on instruction that's available from their website. Here's the link right here. When you import it into the PLC code, it's called this right here. And one of the biggest problems I found with the AOI provided by Balluff is it's almost like they've got a couple. This is a 4-port IO Link master. I think they've got an 8 and a 6 port. I think what they did was they started with the 8 port, and they screwed up the port numbers with regards to how they call things in their AOI. And I can't change the AOI because it's locked down by them. So what I did here is if you zoom in here, so if you you'll see here that they have their physical tags. Well, every tag that is in the AOI, I've given a description to. In the description, if you see the port 1 and port 2 are different, they don't match. So take the description as the gospel, because that's correct, and the descriptions match this arrangement right here, this port 0, 1, 2, 3, 6, and 7. So these bottom ports, 2 and 3, 6 and 7 are your IO Link ports. So that's important to understand. If you don't get that, then you could be possibly confused when you're looking at the code. And okay, let's talk about the PLC code. So I hope you know how to add and configure your own PLC. You know, I've got this PLC right here. This is the completed job. I'm not going to take you step by step. Basically, you know, you come through and you add new module, and you add your EN2TR module, which is your Ethernet IP master, and then you right click on that, and you come through here. If you type in this one right here, this will be you're adding, and then you get to this page right here. So you're adding that. I've given an IP address because that's my IP. This is what the thing is, and then these values right here are what you need to concern yourself with right now. So in the manual here, I show you that this data size here has to be as shown and as in the code in order to mate up with the Balluff AOI. They don't mention the RPI, so I'm just using an RPI of 10 milliseconds and unicast, of course, which is pretty standard these days. So now we've got the information coming in from the real world. It comes into our tags here. And then we have the next thing here. What's the next thing? So, all right. So we've got this main AOI from Balluff here. So let's just show this. So this routine right here, the config routine, the very top, this is their AOI. And basically, you know, you have your input data that we just mapped, your output data, and your config data. This is all coming from this generic module here. And of course, you've got an instance of the AOI, and then you've got a data structure, IO Link port data, for each of the ports. Okay. These are tags that you can choose. That's why the port number and the description match up in this case, because it's not part of their AOI. So all the data, well, let's just go back there for a sec. You get inputs and outputs from that data. And I've labeled the meaning behind all of it. In this case, we're doing sensors, so there's no output data used. The input data, you have, take this port, you've got process data variable. That's what this PDV stands for, high byte, low byte. We've got to flip them around a little bit to get them to come in properly. And then we've got status validation, IO Link mode, and this is all handled through the code. So this right here is discussed on this first page right here. This shows you that the each port has its own tag set. In our case, we've got our SFAW from Festo on port number 2, and we've got a SPU sensor from Festo on port 3. So the two bottom left ports. All right, so this page right here. Okay, so we have our port type. So with the Balluff sensor, the Balluff IO block can be configured so that these 8 ports are either standard inputs or standard with IO Link ports. So when you want to use the bottom 4 ports, then you have to configure them as IO Link ports. And in order to do that, you have to set these bits. So this is port 2, port 3, port 6, and port 7. You basically flip those bits on, cycle power to the Balluff, and it looks at those bits on startup and configures itself for an IO Link port. Port rung number 4 here. So this tells you that this is configured as an IO Link mode port. So this is a confirmation after you've cycled power. And this right here, this device connected, tells you that you have devices connected. We're live or we're not live. So let's go online here. Let's do a download. we will get live. Okay, so we're live, and as we said, we have the device connected here. If I disconnect a device, I'm going to disconnect port 2. Now it's off. See, it's now off. Connect it back up, and we're live again. The ports have been configured all for IO Link, and let's look at the next concept here. So in IO Link, there is the possibility to use a device and vendor ID hard set in the configuration code so that whatever is on that port has to have that based on the configuration. So if you look at this right here in this data C, which is the config data, when you put a 0 in here, I've got a 1 right now. The 0 means there's no validation active. When you put a 1 in, it means that the vendor ID and the device ID are looked at and compared to see if they're correct. I'm showing you here, this rung of code is not required, but for the SFAW, if you want to look at the vendor ID and device ID, this is where the data in the config gets turned on. These 3 bits there, and then the device ID here and here, and the port 2 inputs coming back respond and report the data of the vendor and device ID. And so I'm just showing here what I'm comparing. And if the data matches, then you don't get a failed. If I was to cycle power and flip-flop the sensors around there, you would get a device failed, and then you can do whatever you want with your own code. And this is SFAW on this port, and this is SPU 10 on this port. I don't have anything connected on these ones. All right. Now we move to, we've done this one here, and now we've done the validation. And now we're going to talk about power on the ports. So each IO Link port can have power being fed from the port to the devices. In this particular sample, we're using sensors only, so the sensors don't need power. So these do not get turned on. I leave them off. I don't know if the sensors themselves, if you were to apply power to the pin 2, that they were actually to burn out the sensor. I'm not certain, but these are left off for the sensors. And this right here monitors whether the power has been turned on that particular port. In that case, we are not doing that. The next slide here just shows you that if you have an under voltage, that this fault would come on. And this is the auxiliary power, which is the actuator power, if you want to call it that. And that's it for configuration. So now let's get into the process data of the SFAW. So just like in this one here. So the data from port 1 comes in through the input and output data and config data into this Balluff IOI, and it's shoved into this port 2, port 3, port 6, port 7 data. And that port 2 data, if I look at the data itself, as I showed you earlier, we've got the process data variable coming in on the first 2 bytes, and we shove those into a temporary variable because we need to swap the bytes, and we're going to multiply that by the conversion factor. So the conversion factor is probably something that's worthwhile to talk about here. Okay, so I'm going to open up one of the manuals. So if you, I'm just going to go real quick here. So this manual right here. So we've got on the Festo website, there's a couple of manuals under expert notes because the installation manuals don't seem to describe the IO Link parameters that are inside each of the sensors that they sell. So I've downloaded those, and this is one of them. You know, this looks like this. This is what it looks like. This is the SFAW. And what we're talking about right now is the process to conversion factor. So if I go through here, I think it's page 17. The sensor I have is without temperature. And oh, here they are. So I've highlighted my own manual here, but basically for many of these parameters right here, like process data variable, min, max, and set points 1 and 2, hysteresis, etc., there is a basically a conversion factor. So this number right here is what I'm using right here. It's what the engineering, I call them engineering value, that comes in is being multiplied by, and that gets shoved into the flow value, and then we end up with a value. And then we have these digital outputs from the unit, and it's what's coming back from the sensor. And what I'll do here is I'll show you some live values. So I'm just going to make some air flow through this thing. So you're getting some flow there. The digital outputs, the binary outputs are based on a set point, and you get your data. We're around the 10 mark, 10, 11 mark on the sensor, and it's reflecting that in the value right here. All right, so turn that off. Okay, so that's the process data value. And the next thing that we want to look at or possibly deal with is parameters. So parameters. Okay, the first thing we're going to look at is reading data or parameters. So we're executing a read parameter, and when you do a read parameter, you want to get it through the port, then you have to execute a message instruction. Use a SIP generic message instruction, and the service code, which is 50 decimal or 32 hex here. That's what's used there. That's basically the IO Link service protocol. The 96 hex, which is 150 decimal, is the vendor specific. So the Balluff class. And then the instance number, this is the port number. So if we go back to picture right here, let's pick this picture right here. No, I'll pick this one right here. So because they start at 1, this port down here, port 2, is port 1. So in this sample right here, port 1 is getting data from the SFAW, which is connected to port 2. If you follow suit, this would be port 1, 2, 3, and 4. So port 6 and 7 will be 3 and 4. The only thing that's really difficult about all this is picking the right port number and getting it in your head properly. And this right here, the attribute 3, basically 3 is a read request, a 2 is a write request. Then you have the source element. The source element includes the index and then the subindex. 3, you're saying look at 3 bytes in this array, and then the destination, the information will be put into that tag there when you do a read. So you come through here. This particular one, if I come through here and execute a write, enable is done. So if I go into the sensor, and the set point is 19. So if I change that set point, I'm on the menu right now of the switch. I'll change it to a, let's go 17.7. And toggle this bit, read it in, and it's now 17.7. So we can see here that it works, and so on and so forth. This one right here, as shown before, IO Link. Balluff is the vendor-specific class. Instance is the port number. I'm still talking out to the SFAW. 2, which is a write. And this right here holds the subindex. So if I go up to the controller tags, so this is a write. So I've labeled this as well. So you've got the index, then you've got the subindex, and then you've got the value. So in this case here, as shown in the code, right here, I show all these right here so that you can see it from left to right as a normal format. Got a 017F, which is right here. Sorry, 017F, subindex 0, so 017F, subindex 0, and these are the values you're going to write to the unit. In this case, I want liters per minute. If I change these values and execute a write, which I'm not going to do right now, it will change the display units from liters per minute, for example, to liters per hour or gallons per minute, whatever you put in there. And that's all there is to reading and writing parameters. It's actually quite simple. Once you execute one, you just have to modify the values and so on and so forth. Now, the SPU is basically exactly the same thing, except there's a couple of minor variances in the structure of the input. Again, that would be represented in the Festo description. This one's the SFAW. There's one for the SPAU. So I'm extracting the process data variable from there, doing a byte swap. They also have a conversion factor for the SPA10. Shove it into the PSI. In this case, we're reading PSI. And they've got a couple of BCDs again for various functions. Then we get to the process data variable. It's identical. You come through here. Actually, I'll just show you some real-time data. So I'm just going to show you here. So on my display here, I'm showing 12.3, 12.2, and you'll see there that the PSI is, here, let me zoom in a little bit here. A little hard to do both at the same time, but. All right, so we're looking at this value here. So on the sensor, I've got 15.1, and there's, it's more accurate than the PLC program is on the display. It's only one decimal here, whereas there's many there. And we're going down 6.7. Okay. So that's how the process data variable works. And then we get into the parameters. And the parameters are identical yet again. You know, you've got process data read. You get the done. We're talking the instance, which is the port number. So as I mentioned earlier, that's 1 right here, 2 right here, 3, and then 4 when it comes to the messages. And then the actual parameter index and whatnot that you're reading is right here. So I'm just like it says here, 003C. If you look in the manual, 003C, subindex 1. I'm reading that. I'm getting 87 psi. If I go into the unit here and I scroll these down, let's go to 85.7. Turn it off and on, and now we're reading 85.7. And that's all there really is to it. And that is the day in life in a sensor connected to a Balluff IO Link master to Ethernet IP device. Hope you enjoy this video and accelerate your project. Thanks.